everyone. Welcome once again to Ostino Educational Center, where chemistry is being treated as if it is ABC. Today, like we previously mentioned in our last class, we talked about empirical and molecular formula calculations, and in these calculations, several areas of examples we have looked at, and the solutions we are as well provided. Today, I will be encouraging you to listen attentively to new areas of questions still in the same topic of empirical formula and molecular formula calculation. We are looking at different angles where this question can be calculated and format in approaching the question and arriving at the desired result. So stay tuned to this channel and subscribe to Ostino Educational Center. So today we'll be looking at another example of empirical and molecular formula calculation. Before that, let's go back and look at empirical and molecular formula. In this case, we'll look at their calculation in different formats. In our previous video, we pointed out that there are three basic steps in arriving at empirical and molecular formula. One, we said you must look for the weight of each atom present in the unknown organic compound that went through combustion. Number two, you must get the percentage composition of each atom present in the unknown organic compound. And then finally, you look for the ratio. And I remember vividly that I pointed out that in determining your ratio, you must take into consideration that where the ratio involves fractions, decision making is solely depend on if the fraction can be converted to a whole number after multiplying by a certain whole number. If not, then you must apply the rule of rounding up or rounding down of numbers. That will enable us to arrive at our empirical formula. And so in that case, in the previous video, if you haven't watched the video, you can go back and then take a click, look through them. You see where these examples are solved one after another. And then I think we will be able to drop over 5 examples. Today we'll be looking at another dimension of calculation in empirical and molecular formula. So looking at example number 6. Example number 6, and then example number 6. And that is going back to get the percentage composition and the molecular formula as well as the empirical formula if the formula has been given. Before, we are moving from the unknown compound to the known. Now we are moving from the known to the unknown. So in this case, example number 6 is telling us to calculate the percentage composition of C2H6O. Now in this case, you have already been given the empirical formula. You are expected to get the percentage composition. Now you are solving backward. There are also 3 steps in doing that. One, you get the ratio. In the other case, the first one is get the atomic weight of each element. Now, because you are going backward, you will be looking at the ratio first. After the ratio, you get the relative atomic mass of each of the atoms as well. After that, you multiply to get the weight of each atom. After getting the weight of each atom present, number 3, you will get the weight of the overall compound, and then you get your percentage composition set. So, in solving this problem, one, you first of all get the ratio. You get the ratio of each element. Ratio of each atom involved. Number 2, you will get the relative atomic mass of each atom. You get the relative atomic mass of each atom. Number 3, you get the weight of each atom. Number 4, you will get the weight of the overall compound. You get the weight of the overall compound, and then finally, the percentage of each atom present. Now, these are 5 steps you must take. 5 basic steps you must take. And this step, you must follow them gradually in making sure that this is done. And so you must ensure that the ratio of each atom present, you arrive at them. The relative atomic mass of each atom, you must get them. The weight of each atom, you must get them. The weight of overall compound, you must get them. And then finally, the percentage composition. Thank you. So, step 1 said take the ratio. So we get the ratio of each of them. So we have this CH and of course O in the ratio form. Now to this is the ratio of what? 2. We have 2 here. Is to what? 6. We have 6 there, and of course 1. These are the ratio. So step 1, handle. Step 1, successfully handle. And then of course step 2, get the relative atomic mass of each. Relative atomic mass of carbon is 12. That of hydrogen is 1. Of course, that of oxygen is 16. Now the weight. For us to get the weight of each atom, we multiply the relative atomic mass by the ratio. So this times this, 2 times 12. So you multiply. You multiply. Multiply that. When you multiply that, 2 times this, that will give us the weight of each of the items. So we have 24. This time this we have 6. This time this we have 16. So these are their weights. Now, what is the overall weight? So weight of each atom. Now the next thing is to get the what? Overall weight. Getting the overall weight, we sum them. So overall weight will now be 24 plus 6 plus 16. And when you do that, you are going to be arriving at 46. Now, in getting the percentage composition, which is what we are desired to get, basically we'll have that. What is the weight of carbon here? Weight of carbon is what? Is 24 all over 46. So percentage composition of carbon times 100 over 1. Percentage composition of hydrogen is what? We have 6 all over 46 times 100. Percentage composition of oxygen, we have 16 all over 46 times 100. When you do this mathematically, when you work this mathematically, you are going to be arriving at 1. The percentage composition of carbon will be 52.13%. And of course, that of hydrogen will give us 13.15. And then oxygen will give us 34.72. So you have individually arrived at the percentage composition of each element present, working it backward. Remember, these are the steps you must take.